Now there is another question related with the heat budget of the earth that was asked in 2022. It was the B part of the fourth question of 15 marks. We need to sum up our answer into 225 words. Like 10 marks questions, we need to write in 150 words. So same way we can say that if the question is of 15 marks, then we have to write in 225 words, and if a question is of 20 marks, so we have to sum it up in 300 words. So for 10 marks question they give 2 pages, front side and the back side. 15 marks question 3 pages, and 20 marks questions they give 4 pages. So this there are 3 pages with us. You will write the question. Question number 69. यहाँ पे होती है 69. Write them from the, everyone has bought this previous year's question. The question is indirect. It is based on application of heat budget. Means we have to apply concepts we have studied in heat budget to answer this question. That is what they are doing in geography. Now they are asking indirect questions. Means questions are not directly asked related with the concept. We have to derive variables from the concept and then we have to write our answers. Question is, describe how short-term variations in temperature are related to the processes So we are going to solve this question. It is of 15 marks, means 225 words, 3 pages are allocated to us. Now, before we start answering, we have to underline. The question is on describing. How? Short-term variation in temperature. Temperature we have already said is indicated by concentration of heat. It means that if concentration of heat is on rise, what will happen to temperature? Temperature will increase or decrease? Increase. If concentration of heat is on decline, temperature is on decline. Now, related to the processes of receiving energy from the sun to earth, to earth's surface and dissipating it to the atmosphere. It means that we have, and how the heat is controlled. Heat is controlled by state of balance between incoming shortwave solar insolation and outgoing long wave terrestrial radiation. Remember that incoming shortwave solar insolation received and absorbed is source of surface heating, and surface heating is source of atmospheric heating. Yesterday I have already taught you. Outgoing long wave terrestrial radiation is source of surface and atmospheric cooling. And remember that while you people look at the materials answers given on Google, some site of the coaching, be careful. Now this question has been solved by one of the institute known as Educami. Here you people see outgoing radiation from the sun to the from earth to outer space. They are writing long wave solar radiation. Solar radiation cannot be long wave. These are the mistakes they are doing, and because of these mistakes students are suffering in geography. See here, clearly written shortwave solar radiation. Shortwave solar insolation is the right term. It is not shortwave solar radiation. Insolation it is said. It has been asked in one of the question, insolation. They are not getting inspired. They are not studying the questions also. This is the answer written by Educami. And it is written by the team of Educami. Means they must have a kind of check and balance also. Revising, going through the answers, then loading on the Google and on their site. See here. Shortwave solar radiation. Outgoing they are writing long wave solar radiation. How could be solar radiation long wave? This itself is contradictory. Shortwave solar radiation, long wave solar radiation. These two terms are contradictory. So if you people study some material, some answer on the Google site of the some coaching, and if you people find contradiction to the my teaching, you people raise the question, raise the alarm. Are you people agreed? This is the Educami. Incoming they are writing shortwave solar insolation. Outgoing they are also writing long wave solar radiation. It means that they don't have command over fundamentals of the even physics. Basics of the physics. And these are the very fundamental concepts. Okay? So we have to first make the diagram. Like whatever the diagram I taught yesterday, I am going to divide it into three parts. This is surface. This is surface and again surface, atmospheric top, this is outer space, this is surface. Now, yesterday I gave, if we considered solar insolation, shortwave solar insolation striking at atmospheric top is of 100 units, 35 units are reflected back, known as reflectivity, albedo of Earth. Out of 35 units, 27 units are reflected by clouds, 6 units by suspended particulates, and 2 units by ice caps and glaciers on the surface of Earth. Remember that. How much is left? 65 units. Out of 65 units, 14 units are absorbed by atmosphere, 51 units are absorbed by surface of Earth. That is source of the surface heating. Now, from the 51 units of surface heating, SH means surface heating. I have already taught you 17 units are directly re-radiated back to, this is re-radiation after the heating of the Earth's surface to the outer space, that is called radiation window of Earth. How much is left? 34 units. Out of 34 units, 6 units are transported to atmosphere through process of conduction, 9 units by convection, and 19 units by latent heat of vaporization. So how much now atmosphere has? 34 units plus 14 units, that is, those are 48 units. These 48 units are again re-radiated to outer space. Re-radiated to outer space in form of long wave terrestrial radiation. So remember that the question is about short term temperature variation. Short term means shorter duration of time. Means we have to look into atmospheric and weather conditions which are occurring for a shorter duration of time and interfering into inflowing shortwave solar insolation and outgoing long wave terrestrial radiation. And short term is diurnal. Diurnal means change in temperature according to day and night. It is called diurnal and nocturnal. It is called diurnal and nocturnal. So you know that these are the factors interfering with atmospheric and surface condition controlling short-term temperature variation on surface of Earth and in atmosphere. First is day and night. You know that in daytime we have surface and atmospheric heating. Why? In daytime, Earth receives incoming shortwave solar insolation, which is source of surface heating and atmospheric heating. Night, you know that incoming shortwave solar insolation is not received, whereas longwave terrestrial radiation continue to escape to outer space, that is source of cooling. Second is difference in length of day and night. More is difference in length of day and night, more is the temperature variation. If days are longer compared to the nights, surface and atmospheric heating exceed. If nights are longer, surface and atmospheric cooling occurs. If the length of days and nights are relatively same, then what happens? Difference in temperature is reduced. So more is the difference in length of day and night, more is the temperature variation. If days are becoming longer, like during the solar solstice, 21st of June, when the midday sun is overhead on Tropic of Cancer, okay na? Days are going to be extremely hot, whereas nights are going to be relatively warmer. Getting this thing? On 22nd of December, when nights are means longest in northern hemisphere, so nights are going to be extremely cold, days are going to be relatively cooler, yeah, warmer you can say. Getting this thing? Next is, which are the factors interfering into incoming shortwave solar insolation received by surface of Earth? Cloud. Greater is the thickness, greater is the expansion of the clouds, more is the interference into incoming shortwave solar insolation to the surface of Earth. So, expansion and thickness of clouds. Interfere with the incoming shortwave solar insolation, as well as mist and fog. These are also responsible for the variation in the temperature. While the mist and fog are covering the ground into the atmosphere close to surface of Earth, you know that in the morning temperature, rise of temperature is greatly reduced. Then suspended particulates. Suspended particulates are involved in scattering of the sunlight incoming shortwave solar insolation. That scattering also interfere into incoming shortwave solar insolation received by surface of Earth. Now, snowfall. You know that snow covering the surface of Earth has high albedo. Altitude. You know that as altitude increases, we have more volatile, more unstable atmospheric and weather conditions, including temperature. So these are the factors interfering into incoming solar radiation, incoming shortwave solar radiation received and absorbed by surface of Earth. Now, factors affecting outgoing long wave terrestrial radiation from Earth to outer space. That is again cloud, moisture in air, suspended particulates. Remember that these have ability to produce greenhouse effect, ability to absorb and retain long wave thermal terrestrial radiation. Atmospheric turbulence, Atmospheric turbulence also interfere with outgoing long wave terrestrial radiation. So these are the factors involved into controlling surface and atmospheric temperature. That is the answer. Any doubt you people have? Any doubt? Shall I go ahead? Shall I go ahead? Now next topic is atmospheric composition and structure. Long back there was a question on atmospheric composition and structure. That time questions were long and those were the 60 marks questions. Now we can solve 60 marks questions in 300 marks question of 300 words question of 20 marks. लिख लेना. इसको 20 मार्क्स 300 वर्ड्स का कर देना. This questions could be at 20 marks 300 words. Question is, discuss the nature and composition of Earth's atmosphere. Nature means vertical arrangement of atmospheric layers. That is also called structure of atmosphere. So remember that we have to discuss nature and composition of Earth atmosphere. It could be a 20 marks question with the number of words allocated to us going up to 300. Here, for the clouds, two conditions are important. High clouds and thin, and low clouds and thick. These two properties we have to take into account. Like high clouds which are thin allow incoming shortwave solar insolation to penetrate and come to the surface of Earth. But they absorb and retain outgoing long wave terrestrial radiation. But if low clouds are thick, they interfere into inflowing shortwave solar insolation to surface of Earth. So here is going to be heating, here is going to be cooling. Just not high clouds and low clouds, their thickness is also very important. If high clouds are thin, they will allow incoming shortwave solar insolation to flow up to surface of Earth and surface heating. But they will capture because of the thickness itself is the source of reflectivity. If the clouds have great thickness, they have dense water droplets as well as ice crystals. More is the amount of the water droplets and ice crystals, more is going to be reflectivity of the incoming shortwave solar insolation. And you people must have seen situation during cumulonimbus clouds, which are thick, large and dense. And once cumulonimbus clouds are covering a surface, there is complete darkness even in the midday. More is the amount of the ice crystal, more is going to be albedo, reflectivity. Snow has maximum reflectivity and fresh snow has the maximum. Shall I go ahead? Now, first we have to define atmosphere. So write down, atmosphere is gaseous sphere of Earth. Atmosphere is gaseous sphere of Earth. Covering Earth's surface written. It is a complex physical mixing of atmospheric gases water vapor and suspended particulates. So remember that in atmosphere, water vapor and suspended particulates are transported from Earth's surface. It is clear? So we can safely say that with altitude from Earth's surface, that is always measured from mean sea level, average of sea level, the amount of water vapor and suspended particulates decline. Because these are transported into atmosphere from the surface. Okay, na? And atmosphere is bounded to Earth's surface by gravity of Earth. Atmosphere is bounded to Earth's surface by gravity of Earth. And it is closely interconnected and interacting with other three spheres known as lithosphere, hydrosphere and biosphere. Means atmosphere does not occur in isolation. It is closely and strongly linked with other three spheres and interacting. Means atmosphere could be modified by changes in lithosphere, hydrosphere and biosphere, including the human activities या anthropogenic interventions या interferences या both. Now let us discuss atmospheric composition. First we have to define what is the meaning of composition. What is the meaning of composition? Composition represents proportional presence of atmospheric gases, water vapor and suspended particulates into the atmosphere. So remember that wherever the term composition comes, composition of salinity of oceanic water, composition of internal, composition of making of earth, composition of lithosphere, composition of core of earth, composition of mesosphere of earth, composition of mantle of earth, caste composition, religious composition. Composition means proportional representation of the components of a given phenomena which are involved in making of the phenomena. So question is on composition. So I have already taught you, again we have to repeat the line. With altitude in atmosphere, amount of water vapor and suspended particulates decline. And amount of water vapor, next line, and suspended particulates are subject to geographical variations and temporal variations. Means their amount in atmosphere is never constant because these are released from the surface. These are also deposited on the surface with the rain. So their amount is not fixed into the atmosphere. Like this time, amount of water vapor in the rainy season in the atmosphere is high. During the summers, it was low. Suspended particulates were high during the winters. Suspended particulates are low with the rainfall. Getting this thing? Now, in a given volume of atmosphere, in a given volume of atmosphere, which is dry, nitrogen contributes nearly 78%, oxygen contributes 21%, and other gases like argon, carbon dioxide and rest of the trace gases contribute rest of 1%. Now we need to represent it. That is by using pie diagram. So nitrogen is 78%. Oxygen is 21%. And rest we can write like this. Like we can extend this. This is for argon, carbon dioxide and rest of the trace gases. And here we need to write composition of atmosphere. So in a given volume of dry air, nitrogen contributes, it is volume, it is not mass, remember it. In the prelims it could be asked, even in the interview. In a given volume of dry air, nitrogen contributes 78%, nearly 78%. Oxygen contributes 21% nearly, and rest 1% is contributed by argon, carbon dioxide and rest of the trace gases. Trace means in a very extremely low amount. If the present amount is extremely low, that is called trace. So this is the composition of atmosphere. You need to write, while you are making this diagram, you need to write atmospheric composition. Means while we are representing proportional presence of elements, variables, parts involved in making of a phenomena, that is called composition. Now what is the next section of the question? Nature of atmosphere. Nature of atmosphere. That is described through structure of atmosphere. Structure of atmosphere describes nature of atmosphere. Like structure of caste is the nature of caste, vertical stratification of caste on the basis of concept of pollution and purity. That is called nature of caste. So here question is on nature of atmosphere, means we have to describe structure, means vertical arrangement of atmospheric layers. Vertical arrangement of atmospheric layers is called structure. That is the nature of atmosphere. Now, if we are looking for vertical arrangement of atmospheric layers, so there must be parameters to identify layers and their vertical arrangement. These parameters are temperature, density, and the interlinkages between altitude and temperature. These three parameters are used to determine vertical arrangement of atmospheric layers, known as structure of atmosphere, and that is also described nature of atmosphere. Now, these are the atmospheric layers. We classify atmospheric layers into two parts: major layers and transitional layers. This way you can This way it is going to be easy to memorize. Memorization is going to be easier. Understanding is going to be easier in form of the chart. Remember that major layers are thick. Transitional layers are going to be thin. Now let us describe their thickness. So their thickness is always measured from sea level. And what is the most important parameter? The interconnection between altitude and temperature. So major layers are going to be troposphere, it is extending from sea level to 15 kilometer, means its average thickness is of 15 kilometer. And with altitude, temperature decline. Above troposphere, we have major layer as stratosphere. It is extending from 20 kilometer from sea level to 50 kilometer from sea level. Means it is extending nearly up to 30 kilometer. And here temperature increases. So contrast is visible between troposphere and stratosphere. In troposphere, with altitude, temperature declines. In stratosphere, temperature increases. Then mesosphere, it is 51 kilometer to 80 kilometer, extending nearly up to 30 kilometer, you can write. Temperature again decline with altitude. Why it is declining, increasing, we have to explain, because we have to discuss. And above mesosphere we have thermosphere. It is extending above 90 kilometer. So this is going to be thickest layer, thermosphere, and it is extending up to the atmospheric top, which is highly rarefied. And here again temperature increases. In between we have transitional layers. Between major layers we have transitional layers which are thin. That is why thickness is not described. These transitional layers are known as tropopause, stratopause and mesopause. Tropopause between troposphere and stratosphere, stratopause between stratosphere and mesosphere, mesopause between mesosphere and thermosphere. These are going to be thin, and temperature, altitude and temperature. With altitude, temperature is unchanged in these thin and transitional layers. We can solve this mystery over here itself. Why? In tropopause, stratopause and mesopause, temperature does not change with altitude. If temperature does not change with altitude, okay na? Yeah, with place. That phenomena in geography is known as isothermal. Remember, these layers are isothermal. Okay na? In a geographical region, if the geographical phenomena are unchanged, that is called isotropic. So these thin layers which are transitional between the thick major layers which have decline या increasing in temperature with altitude are isothermal in nature. Why these are isothermal? या temperature is unchanged with altitude? Because of these transitional layers are zone of conflict, zone of confluence of major layers which have contrasting thermal properties. Like in troposphere, we have decline in temperature with altitude. In stratosphere, we have increase in temperature with altitude. So troposphere and stratosphere merge at tropopause. So that becomes zone of merger is thin and without change in temperature with altitude. It is understood? Only one person is saying. How many people are present? His response is coming. Now, what is left with us? We have to make the diagram. Remember that altitude or depth are always on the y-axis and geographical phenomena like temperature, pressure, oceanic salinity, means these topics are going to be on x-axis. So here we have nothing to do with the depth. So on x-axis we have temperature, on y-axis we have altitude. Because depth is not required here, because we are measuring temperature, means interlinkages between altitude and temperature. So, and altitude is always measured from mean sea level. That is described as mean sea level. So remember that these are the figures of temperature you are required to remember. It could be useful for prelims. 15 degrees centigrade, 0 degrees centigrade, minus 80 degrees centigrade and minus 120 degrees centigrade. These four figures are important. This is the troposphere, then tropopause, then stratosphere, then stratopause, mesosphere, then mesopause. Temperature in mesopause is nearly minus 120 degrees centigrade. So mesopause has lowest temperature in atmosphere. This question has been asked in the prelims, remember it. And then above mesopause we have thermosphere. Remember that troposphere, tropopause, stratosphere, stratopause, mesosphere, mesopause. Together these layers are also described as homosphere. Because here mixing and distribution of four major gases are uniform. Which are the four major gases? Nitrogen, oxygen, argon and carbon dioxide. Mixing and distribution Our 4 major gases are uniform. That is why these are called homosphere. Thermosphere is part of heterosphere. Thermosphere is part of heterosphere. Here, atmospheric layers are arranged according to their molecular and atomic weight. Means here is the process of differentiation. Whenever the process of differentiation, heterogeneity occurs, plurality occurs. Remember it. Wherever is process of integration, unity occurs, homogeneity occurs, uniformity occurs. Integration is the source of geographical integration, geospatial integration is source of uniformity, unity. And differentiation is source of geographical particularity and heterogeneity. Later on, these concepts are going to come into the perspective on geography. Geographical differentiation and geographical integration. And heterosphere, thermosphere, which is heterosphere, is classified into these layers. Nitrogen layer, then oxygen layer, then helium layer and hydrogen layer. So thermosphere is heterosphere. Heterogeneity occurs because here is differentiation of thermosphere into the atmospheric layers dominated by nitrogen molecule, oxygen atom, helium atom and hydrogen atom. Remember that it is molecule, it is atom. Molecular weight of nitrogen is 28. Don't write O2. Otherwise, O2 will become denser and heavier and come below the nitrogen. Nitrogen is here heavier than oxygen because it is molecule. N2. Helium and hydrogen, they are in atomic state. Shall I describe 4 major layers and their properties? Diagram is understood. Troposphere, temperature declines. Then tropopause, temperature is constant. Stratosphere, stratosphere temperature increases. Stratopause, temperature constant with altitude. Mesosphere, mesopause and thermosphere. Troposphere, tropopause, stratosphere, stratopause, mesosphere, mesopause are described as homosphere of atmosphere, in which 4 major gases are uniformly mixed and distributed. Thermosphere is also described as heterosphere. Here process of atmospheric differentiation occurs and the heterosphere is described as nitrogen layer, oxygen layer, helium layer and hydrogen layer according to distribution of atmospheric molecules and atoms in respect of their molecular weight and atomic weight. Shall I describe these 4 layers and their properties? Because the question is on nature. So we have to describe atmospheric nature and the nature of the atmospheric layers too. Ionosphere, I am coming. Ionosphere is part of the thermosphere. Ionosphere is part of thermosphere, where concentration of ions are increased. sphere. Atmosphere is most dynamic sphere of the earth. And it is gaseous. So most dynamic. So I told you yesterday. First we study something which is standardized, reference and normal. And then we study something which is shifting, या contrasting, या departing from the normal. We are studying the normal scenario. Even you are sitting on your chair with your laptop. Do you think you are completely static? Your mind is not moving, your neck is not moving, your eyes are not moving, your eyes are not blinking. थोड़ा सा तो mature हो जाओ यार. That is why you people are cheated. Yesterday I told you, nothing is completely static, nothing is completely dynamic. In any subject, we start with the reference scenario, standardized scenario and normal scenario. Even in troposphere, there is a concept known as temperature inversion. In certain surface and atmospheric conditions, temperature increases with altitude. That is called temperature inversion. Questions are there even in the GS mains and optionals. So many questions are there. Yes, mixing occurs in troposphere, but mixing does not occur in stratosphere. Tropo का मतलब ही होता है mixing of the air with the turbulence, rise of hot and lighter air and sinking of cold and denser. अभी आ रहा हूं, अभी तो आ रहा हूं ना troposphere पे. Remember that in respect of other three spheres, hydrosphere, lithosphere and biosphere, atmosphere is most dynamic and most fluid in nature, being gaseous in nature. That is why I am teaching at climatology first. Then I will teach the geomorphology. Geomorphology has less fluidity. Atmosphere has high fluidity and randomness, high entropy. So if you understand the high level of entropy, easily you can understand the low level of entropy. And means going from the toughest to the easiest, not the easiest to the toughest. So that teaching easiest, that will give you a kind of imagination that geography is easy. It is halwa, it is the cake. 2 months you study and the course will be finished and you will top. Okay, na? That is why I am teaching the toughest of the sections, geomorphology and climatology first. So what is our emphasis? To understand the order as well as to understand the anomaly, entropy, disorder. Order is something which is standardized, something which is normal, something which is reference. An anomaly is something which is shifting or departing from the normal. Got it? Shall I go ahead? Describe troposphere, stratosphere. Okay. Troposphere. So these are the properties of the troposphere. Average thickness is 15 kilometers. Average thickness at equator is 18 kilometer, at poles is 8 kilometer. Means thickness of troposphere, altitude is always on x-axis. Declines from low latitudes to high latitudes. We need to explain why. I have already taught you solar insolation, surface and air temperature declines from low latitudes to high latitude. So the thermal convection and rise of hot and lighter air. More is rise of hot and lighter air, more is the thickness of troposphere. Means troposphere is thermal convective in nature. How thermal convection occurs? With surface and atmospheric heating. With the atmospheric heating from surface, hot and lighter air rises. Hotter it is, lighter it is, more vertical distance from the surface it will cover in the troposphere. So the increase in thickness. This thermal convection in form of rise of hot and lighter air is source of turbulence. Turbulence is source of mixing of air. Remember that turbulence is also a source of moderation in temperature. If turbulence in atmosphere occurs, mixing of air occurs and temperature is moderated. Remember that temperature declines in troposphere with altitude. Temperature declines in troposphere with altitude. Now we need to write why. First point, yesterday I have already explained. First point, surface heating is source of tropospheric heating. Here, from here we can derive. So wherever surface is more heated, tropospheric thickness is increased. So again we can say, in summer season, troposphere is thicker compared to the winter season. We can also draw the conclusions. That is what they are doing in the prelims. They are not asking direct questions. You have to draw the inferences from the topics you have studied. And if you have done the PYQ, drawing inferences are very easy. People are launching their test series without solving the PYQ. I can construct my own questions and answer. That is not going to show my greatness. If I am able to solve the questions created and designed by UPSC for civil services, that shows the greatness of the teacher and the greatness of the students. And that is extempore, without any copy, kitab, laptop. This is the age of laptop teachers. You take away their laptops, they will start crying. You take away their laptop and PDF, they won't be able to teach. Teaching with PDF is like reading newspaper reading. What is your thinking? You people also want to study from laptop teachers, PDF teachers? That is the situation of PDF teachers. Long wave solar radiation they are writing. For incoming also they are writing short wave solar insolation. आगे चले तो temperature declines with altitude in troposphere because first point tropospheric heating is supported by surface heating. So as altitude from surface increases या distance from surface increases, what happens? Temperature declines. Second point, air is thick close to surface. Because air density declines with altitude. So thick air has better capacity to absorb and retain heat rather than thin air. So close to surface air is thick. That is why its heating is more. But primary factor is surface heating is source of heating troposphere. Third factor, water vapor, suspended particulates, other greenhouse gases like carbon dioxide are in high amount close to surface, absorbing and retaining heat. So remember that there are three factors controlling decline of temperature with altitude in troposphere. First, surface heating is source of tropospheric heating. Second, air is thick close to surface of Earth. And third, amount of water vapor, dust particulates, suspended particulates which capture and retain is high close to surface of Earth. And what is the rate of change of temperature? It is 6.5 degrees centigrade per kilometer. It is known as normal environmental lapse rate. This is rate of decline of temperature in troposphere. Got it? Shall I go ahead? Now, troposphere is source of formation of clouds, storms, rain, means weather and climatic conditions are formed within troposphere. Occurrence of winds, occurrence of turbulence, formation of clouds, movement of clouds are largely within troposphere. Now, which is the next layer? Stratosphere. This is the diagram of stratosphere. So, stratosphere is between tropopause and stratopause. And here temperature increases with altitude. Now question arises why? And it is extending from 20 kilometer to 50 kilometer from sea level. Now, question arises why temperature increases in stratosphere. Stratosphere contains ozone molecules which absorb ultraviolet radiation, which is a form of electromagnetic radiation outflowing from sun. It is source of stratospheric heating. It is source of stratospheric heating. And because of, and from where ultraviolet radiation is outflowing from sun. Sun is the source of outflowing ultraviolet radiation. So naturally temperature is going to increase from low altitude to high altitude. Because source of ultraviolet radiation is not terrestrial radiation. Radiation emitted by surface या atmosphere of Earth going to outer space. So here temperature increases with altitude. So in stratosphere, warm and lighter air is above cold and denser air. Warm and lighter air is, because temperature is increasing, warm and lighter air is above cold and denser air. So remember that it is going to be non-convective. This is contradictory to the troposphere or not? Troposphere is convective in nature. Means it is without turbulence, because there is absence of vertical movement, rise of hot and lighter air and sinking of cold and denser, because warm and lighter is above cold and denser. In gravity environment of Earth, this cannot rise, this cannot sink. And that is why it is stratified. Getting this thing? And remember that is why stratosphere is used for air transport. Troposphere is largely not used for air transport because of presence of turbulence. And troposphere, and second point, stratosphere has largely scarcity of water vapor, clouds and suspended particulates. Largely scarcity I am saying. In exceptions, clouds do occur, water vapor do occur. Exceptions do not make the rules. While we are talking about rules, we are talking about general and normal conditions. Now, mesosphere. Mesosphere occurs between stratopause and mesopause, and it is extending from 51 kilometer to 80 kilometer from sea level. Okay, now temperature declines with altitude in mesosphere. Why? Ozone molecules do not occur above 50 kilometers from sea level. And mesosphere is source of formation of meteors. ये क्वेश्चन पूछा हुआ है पीटी में. Now, final thermosphere. Thermosphere extends above 90 kilometers from sea level up to the atmospheric top. Remember that atmospheric top is leveled off. Troposphere has variation in thickness, not the atmospheric top. There was a question in prelims. Atmosphere is thicker above equator and thin above poles. That statement was wrong. Troposphere is thick above equator and thin above poles, not the atmospheric top. You know that the atmosphere is fluid, gaseous. Under gravity environment, fluids have tendency to level off their top. If you do not believe, you put water into the bucket and see how it is leveling off its top. Yeah, put some pot into the bucket full of the water. It will level off. Be careful. आगे चले तो thermosphere is above mesopause. It is extending above 90 kilometers from sea level, and here temperature increases with altitude. Now we need to explain why. Source of heat and temperature is inflowing ionizing radiation from sun. With high energy, like X-ray, is ionizing radiation. High frequency of ultraviolet radiation is ionizing radiation. With high energy, ionizing radiation is source of excluding electrons. With movement of negatively charged electrons which are excluded from atoms, and the positively charged atoms and molecules energy and temperature are created. Remember that is why part of thermosphere, which is mainly extending from 90 km to 640 km with high concentration of ions, is called ionospheric. sphere. So part of thermosphere which is extending from 90 kilometer to 640 kilometer with high concentration of ions present in form of negatively charged electron and positively charged atoms and molecules is described as ionosphere. And ionosphere is source of reflection of radio waves. Remember that radio waves have longest wavelength in electromagnetic radiation. Yeah, shortest frequency and energy. So these are reflected by the ionosphere. High energy radiation like microwaves cannot be stopped by ionosphere. So that is source of reflection of radio waves and radio communication. Remember that this ionizing radiation itself is source of heterogeneity and thermosphere. Heterogeneity in thermosphere. In form of nitrogen layer, oxygen layer, helium layer and hydrogen layer. Means what is source of differentiation and heterogeneity? That is ionizing radiation, या high energy radiation outflowing from sun to earth, penetrating through atmospheric top. So this is the nature of the atmosphere. So how many questions we have solved so far? On the atmosphere itself, 3 questions. नहीं, GS में हो है क्या तुम्हारे पास? उसमें नहीं है, मेंस ऑप्शनल में नहीं है, GS का क्वेश्चन है, GS मेंस का क्वेश्चन. One year, 2 years back, there was also a question in GS Men's first paper on troposphere. Take 5 minutes break and then we are going to start the next topic. So how many people have bought this? Everyone has bought. Savinder Singh, physical geography and this. And if you people read anything on Google related with our topics and coming across any kind of inconsistency with my teaching, let me know. Otherwise, you people must have seen how people are writing their answers. Shall I start? You people want 2 minutes more. Now, last topic related with temperature, and then we will start pressure belts, beams and tricellular model. Next topic is temperature inversion. See how many questions are there from temperature inversion. Write down, आ जाना. Inversion of temperature 95. नेक्स्ट कर देना वहां से प्लस. Write short note on inversion of temperature. इन मार्क्स कर देना. फिर और आया है, और भी आया है ना. अब वहीं उस तरफ एक चेयर रख लो, वहीं पे बैठ जाए, उधर से आ जाए करो. हम्म 13 में है. 13 में हाँ. यस 23 में भी है, ये लिख देना. GS में था. हाउ डज इन्वर्जन. ये 10. How many people of this class are in Delhi? Just 3 people. And how many people are online, means out of station? Delhi me sir means Delhi Now temperature inversion, inversion of temperature. 3 questions are there, 95, 2010 and 23. Means in the mains geography optional questions are repeated. Means if someone has seriously done with the PYQ, they are not required to go to the test series. They can have their test series at their home itself, rather than paying 30,000 rupees to the idiot institutes with the idiot teachers. Here, that is there with you. Temperature inversion 95, temperature inversion 2010, temperature inversion 23. Shall I start my lecture? So you people have written question. Yes, shall I write short note on inversion of temperature 95, 10 marks, 150 words. Write a short note on inversion of temperature 2010, 15 marks, means 225 words. Again repeated in 2013, 2023, 15 marks, means 225 words. Now, what we studied in troposphere. In troposphere, temperature declines with altitude, with rate of decline 6.5 degrees centigrade per kilometer. So what is going to be described as temperature inversion? Remember that temperature inversion is also an anomalous condition. Okay, na? Instead of this situation, if temperature increases with altitude, see here, this is environmental or normal lapse rate with decline of temperature with altitude in troposphere. Why? Surface heating is source of tropospheric heating. Part of the troposphere which is close to surface is heated more compared to something which is relatively above the surface with altitude. So, this is the diagram indicating a state of temperature inversion. Temperature on x-axis altitude on y-axis. This is called temperature inversion. So write down definition of temperature inversion. Rise in atmospheric temperature with altitude is described as temperature inversion. Temperature inversion is an anomalous condition. Temperature anomaly, you can write also temperature inversion. Temperature inversion is an anomalous condition. Produced in the presence of very specific particular surface and atmospheric conditions and situations. Okay, na? It is not a general situation. Means temperature inversion is not a normal situation in atmosphere. It is produced in very specific particular surface and atmospheric condition we need to explain. Types of temperature inversion. Remember that there are multiple types of temperature inversion, but that is the scope of our civil services examination. 6 to 7 types of temperature inversion are there. But most importantly, there are 2 types of temperature inversion we need to write. Because here word limit is 250. Types of temperature inversion. First is lower air temperature inversion. And second is upper air temperature inversion. These are most important types of temperature inversion. What is the normal situation? Temperature declines with altitude. What we need to explain? Surface and atmospheric conditions producing increase in temperature with altitude. First situation I am taking lower air temperature inversion. Lower air temperature inversion is produced in the presence of following conditions. Long, cloudless, windless, turbulence-less, winter nights. This is situation first. Yeah, above cold oceanic currents, situation D. And third, inflow of hot and humid winds over cold surface. Okay, na? In these three situations, in the lower part of the troposphere, temperature inversion is formed. Lower part of troposphere, which is close to surface of Earth. First, in the presence of long, cloudless, windless, turbulenceless winter nights, in the presence of cold oceanic current flowing from high latitudes. So, you know that cold oceanic currents flow from high latitudes to low latitudes. Yeah, if there is a wind flowing over cold surface, that cold surface could be continental surface या oceanic surface. Continental surface is colder in the winter season. Oceanic surface is colder with the presence of cold oceanic currents. So remember that in these three conditions, there is presence of overcooled surface. Overcooled surface. That could be oceanic surface, continental surface, या both. In the long winter nights, which are windless, turbulenceless, cloudless, continental surface is cold. One property of the air you are required to remember. That property of the air is poor conductor of heat. Air is poor conductor of heat. So, flow of heat from air to air is poor. So, remember that in lower part of the troposphere, I am saying कि overcooled surface temperature is 5 degrees centigrade. So, air in contact with the overcooled surface in these three conditions. Because it is in contact with the surface, with the flow of heat from the air to surface, it is also cooled. Like it becomes cold and denser. Its temperature is now close to 5 degrees centigrade. But the air above, since air is poor conductor of heat, remain warm and lighter. Air in contact with the overcooled surface in these three conditions become colder and denser. Whereas air above, because air to air flow of heat is poor, flow of heat occurs through the interface of surface to air या air to surface. But air to air flow of heat is poor. Air is poor conductor of heat. This property you are required to memorize. That is why we use blanket. It is not the cotton या ruई which is preventing outflow of heat. It is the air in the cotton, in the ruई, in the jackets, air inside of the jackets. That is why floppy jackets are more warm compared to the thinner jackets. That is why different layers are put so that between the layers, within the layers there is air. So air is poor conductor of heat. Remember, these things are very important for the prelims basics. Getting this thing? So air close and in contact with the overcooled surface get colder and denser, whereas air above remain warmer and lighter. This is the situation in which temperature inversion is produced. So remember that in the case of temperature inversion, warm and lighter air is above cold and denser air. Because this is the diagram of temperature inversion. Warm and lighter air is above cold and denser air. It is going to be convective or non-convective? Answer. Non-convective. Because they are asking atmospheric conditions. Cold and denser air cannot rise and warm and lighter air cannot sink. It is going to be turbulence-less. So atmospheric conditions are going to be stable or unstable? Stable and stratified. If the air in contact with the surface contains water vapor, then you know that condensation will take place. And that could be source of formation of mist and fog. Means distribution of water droplets into the air close to surface of earth. If the density is low, that is called mist. If density of the water droplets close to surface of earth hanging in the atmosphere is high, that is called fog. So temperature inversion is source of formation of mist and fog. As soon as the winter will start in the continental part of India, you will see formation of mist and fog. As the length of the nights become longer. Remember that on positive side, mist and fog are source of providing moisture to the plants and soil. On the positive side. If the foggy conditions are normal, mist is normal, not too dense. On the negative side, mist and fog are source of interfering into transport and communication. आगे चले. Remember that in urban and industrial region, this mist and fog is mixed with industrial smoke. Forming poisonous smog, which negatively affect health of the people, particularly respiratory systems. Asthmatic attacks are increased. That is why in the winters, in the morning, people with the asthma, respiratory distress are advised to not take the morning walk. Since atmospheric conditions are stable above industrial and urban regions, smog takes the form of dome. That is called pollution dome. Because windless conditions, turbulence conditions are strengthened with temperature inversion. Cold and denser air close to surface of earth, above warmer and lighter. They cannot move. They can't have the vertical movement. So that is described as pollution dome. If there is light wind, so dome is converted into pollution plume. Remember that Delhi is continental in nature. So, temperature inversion and related fog and smoke are very common. Whereas fog and smoke are not common in the cities on the coast like Mumbai, Kolkata, Chennai. That is why these are less polluted compared to Delhi. Of course, Delhi has high number of automobiles too compared to these cities. But the natural and geographical conditions also support rising pollution in Delhi. And now the problem is added, increased by burning of the parali by the farmers in the surrounding regions. It is understood. Shall I go to upper air temperature inversion? अरे respond करो यार, I am not teaching to the bhoots. क्या you people are equivalent to the ghost? अभी एग्जाम शुरू नहीं हुआ, तुरंत ही तुम लोग एकदम इतना पैसिव हो गए भाई. Why you people are so passive? I always believe in teaching with interaction. नहीं interact करोगे तो फिर demotivate होऊंगा. So with the demotivation, my performance is also going to be compromised. It is the responsibility of the students to bring out best of the teachers. Interaction is not one way, it is always two-way process. More you people interact, more I interact with people, more our understanding is going to grow. आगे चले. Now, upper air temperature inversion. That though I have already taught you. That is also described as upper air thermal temperature inversion. And it is represented by stratosphere, which I have already described. Why upper air temperature, thermal temperature inversion is formed? That is by stratospheric heating, as ozone molecules absorb ultraviolet radiation, that is source of heating of stratosphere. So, in stratosphere too, warm and lighter air is above cold and denser air. Warm and lighter air is above cold and denser air. So, that I have already taught you. It is non-convective, non-turbulence, relatively cloudless, moistureless, dustless. It is stratified. So remember that this upper air thermal temperature inversion in stratosphere protect stratosphere and its ozone molecules. From disintegration, from their depletion. Otherwise, had been stratosphere convective in nature, there would have been flow of the water vapor, flow of the dust, suspended particulates, and ozone layer would have been destroyed. So, this upper air thermal temperature inversion which prevails in stratosphere helps in protection of stratosphere. Now, next topic. So, all the chapters related with atmospheric temperature with their vertical distribution, horizontal distribution. No, one topic is left. One topic is left. One topic is left on temperature. Global distribution of temperature. Factors and global distribution. Next topic is global distribution of temperature. Global distribution of temperature. Remember that here we are studying global distribution of surface and atmospheric temperature. These are the indicators, parameters used for studying global distribution of temperature. First, diurnal temperature. Remember that diurnal temperature is variation of temperature in a given date according to day and night. And diurnal temperature is only recorded temperature, rest are calculated out of diurnal temperature. So diurnal temperature indicates maximum and minimum. That is printed in newspapers too. Provided by in India, Indian Meteorological Department. A genuine request to you people, read something on IMD. Because it is an institution. Understanding of institutions is very important because that helps in disaster management too. So you can go to the Google, this is just factual, so you can read on the IMD. It is going to be important because these kind of things cannot be taught in the optional class. There are limitations before the teachers, and these are the things related with the micromanagement. A student can do these kind of things their own. Remember that in the time of crisis, micromanagers prevail. Why 3 people died in the basement? They could not manage themselves. They were too slow to respond and react. I am not saying that there was not fault of MCD or there was not fault of the rouse. But now even students are very slow in reactions. Most of the time they are attached with the screen and the earbuds. Even walking on the roads, they have something plugged inside their ear. So situational awareness is now minimized. So once situational awareness is minimized, how you can react and respond to a situation which is occurring suddenly? Am I right? Yeah, I am wrong. So throughout the day and night, don't have contact with the screen. There must be limited interaction with the screen of your mobile and computer. That is why I hate teachers with teaching PowerPoint presentation. They become part of the problem, not part of the solution. They are part of the problem, not part of the solution. You are required to become part of the solution, not the part of the problem. So remember that when solar insolation is maximum, 12 p.m. midday, but the maximum temperature for a cloudless and rainless day, which is described as normal day, is between 2 p.m. to 4 p.m. Because solar insolation is directly not responsible for atmospheric heating. There is always a delay in the process and effect, that is called time lag. Remember this phenomena, time lag. So solar insolation for a cloudless and rainless day is maximum at 12 p.m. but the surface and atmospheric heating with the time lag is maximum between 2 p.m. to 4 p.m. And minimum temperature is of course before sunrise. So its average is calculated by calculating mean of maximum and minimum. That is called average diurnal temperature. So remember that cloud and rain are also source of short-term temperature variation. Cloudy days are cooler, cloudy nights are warmer, and that is also called diurnal range. Diurnal range is going to be maximum minus minimum. Maximum temperature of a given date and minimum temperature of a given day. That called diurnal range. So tell me one thing, diurnal range is maximum during cloudy and rainy day or minimum during cloudy and rainy day? Fluctuation of temperature. Range is also described as fluctuation. बताओ भाई. Diurnal range of temperature is high during cloudless and rainless day या cloudy and rainy day? Diurnal range of temperature is high during cloudless and rainless day. Rapid heating and rapid cooling. Diurnal range of temperature या fluctuation of temperature is reduced during cloudy and rainy days. Got it? लिख लेना भाई. Diurnal range of temperature is high on low altitude या high altitude? Diurnal range of temperature is high on high altitudes. Highlands like mountains, hills have high fluctuation of temperature. All these parameters could be written into the temperature factors responsible for temperature variation. I have taught you that geography is multi and interdisciplinary. Facts will come for the previous topics in the next topics too, which are going to be taught in the future. Be careful. All the facts and figures related with the phenomena cannot be taught at one place. Then we calculate mean monthly temperature. That is by averaging of diurnal average of every day. Like if there is a month of 30 days, that is written as summation. Average diurnal mean monthly temperature summation 1 to 30 diurnal temperature divided by number of days. Means diurnal average temperature. Diurnal average temperature of all 30 days, 29 days, depends on number of days in a month, are added and divided by number of days. That is called mean monthly temperature. So, mean monthly temperature we have from January to December. Remember that mean monthly temperature is a calculated. Diurnal maximum and minimum are only recorded using thermometer by stations of meteorological departments. क्योंकि ये नहीं समझोगे फिर the distribution of temperature is going to be difficult. Got it? Now, annual temperature is addition of mean monthly temperature of 12 months divided by 12. That is called annual temperature. That is described as an annual range of temperature, mean monthly temperature maximum minus mean monthly temperature minimum. That is called annual range of temperature. So, what is short-term temperature variability and short-term temperature variation? Short-term temperature variation is indicated by diurnal maximum and diurnal minimum and their differences. That is why short-term atmospheric conditions are called weather and long-term atmospheric conditions calculating by taking average into account, mean into account, those are called climate. So, there is a difference in weather and climate. Climate represents a long-term atmospheric condition. That is average atmospheric condition. Average is taken for a longer duration of time, like decades, centuries, year. Weather is short-term indication of atmospheric conditions, like weather of Delhi today. We can't say climate of Delhi today. Climate will represent its annual conditions, overall conditions. Like we say climate of Delhi is continental, but weather is not continental. Sometimes monsoon winds inflow into Delhi. Western disturbances inflow into Delhi producing cloudy and rainy conditions. Those are called atmospheric and weather conditions. Okay. So, these are the parameters we are required to remember. Be careful in the prelims. And remember that if diurnal temperature is hotter than normal, that is called heat wave conditions. So, remember that heat wave conditions are also important for contributing factor into short-term temperature variation, like Delhi in the summers under influence of the loo producing heat waves. If the temperature is unusually high for a given place, that is called heat wave condition. If it is unusually low, unusually colder, so that is called cold wave condition, like Seet Lahar in Delhi. So, heat wave conditions, cold wave conditions are also responsible for short-term temperature variation. अब वहां पे आप लोग इसको लिख लीजिएगा. These are the examples which help in maximization of the marks. If one of my student can score 326, you people also can score. Since I never advertise my name and all that, I am never involved in the creation of narratives false narratives, oversimplified answers and overgeneralized answers to the students. Keeping them in comforting illusions. आगे चले. So now we are going to study first factors controlling distribution of temperature, distribution of global temperature. These are the factors. First is latitude. Second is altitude. Third is distribution of land and water. Next is thermal properties of inflowing winds, thermal properties of inflowing oceanic currents, size and density of plant and vegetation. These are the factors controlling global distribution of surface and atmospheric temperature. वो उसमें नहीं है. Now first is latitude. First point. First point, latitudinal distribution of temperature. Annual temperature declines in general. Annual temperature declines in general from low latitudes to high latitudes. Why? Annual solar insolation due to increasing tilt. Declines from low latitudes to high latitude. Because solar insolation is source of surface and atmospheric temperature. Tilt is increasing from low latitudes to high latitude. Second point, however, within low latitudes, annual temperature is highest at tropics. Tropics means Tropic of Cancer and Tropic of Capricorn. Why? I'll teach later on. Tropics are covered with the cloudless, rainless tropical deserts. That is why there is anomalous condition. In general, from low latitudes to high latitudes, annual temperature is declining. But you look at the diagram, at the tropics means Tropic of Cancer and Capricorn. Temperature is slightly high compared to the equatorial region. That is because of tropics are covered with cloudless, rainless, tropical deserts. And equatorial region is covered with equatorial rainforest. So where temperature is going to be high? Something which is covered with the densest forest of the world, with the rainfall every day between 2 p.m. to 4 p.m. Yeah, something which is within the low latitudes and cloudless and rainless. This is anomalous. This is called anomaly. The rule is annual temperature declines from low latitudes to high latitudes. But exceptions are within the low latitudes, annual temperature is not highest at equator. Yeah, in equatorial region, it is highest at tropics. Next point. In northern hemisphere, mean monthly temperature is highest for July. Why? Midday sun is overhead on Tropic of Cancer on 21st of June. Midday sun means 12 o'clock sun is overhead on Tropic of Cancer on 21st of June. With the 1 month delay in the northern hemisphere, July is hottest. And in northern hemisphere, January is coldest. Why? Midday sun is overhead on Tropic of Capricorn on 22nd of December. So with 1 month delay, January is going to be coldest in northern hemisphere. It is clear? And vice versa for the southern hemisphere. You people can write your own. In southern hemisphere, January is going to be hottest and July is going to be coldest. We are not taking here into account rest of the factors. We are only taking into account latitudinal factors. And remember, next point. Annual range of temperature. Increases from low latitudes to high latitudes in general. Annual range of temperature increases from low latitudes to high latitudes. Because low latitudes are winterless. There is no winter season in the low latitudes. On equator and close to equator, there are uniformity in the weather and climatic conditions. Throughout the year, equatorial region are hot and humid. So annual range of temperature in general increases from low latitudes to high latitudes. As we travel towards high latitudes, we know in the summers days are very long and in the winters nights are very long. So contrast in length of days and night are increased towards the high latitudes. It is clear to you people? Shall I go ahead? Now next factor is altitude. Next factor is altitude. That I have already taught you. You people write. With altitude in troposphere from sea level, temperature declines. At first point, I have already taught. Surface heating is source of atmospheric heating. Second point, air is denser close to surface of earth. And third, high amount of water vapor and suspended particulates close to surface of earth. Getting this thing? Next point, in altitude itself, diurnal and annual range of temperature is high on high altitudes. Where air is thin and lighter. That is why if you go to the highlands like Simla and all that, as soon as sun sets, night appears, there is massive drop in atmospheric and surface temperature within 1 hour. Okay, now what is third factor? It is clear to you people? Latitude and altitude we have covered. Distribution of land and water. Remember that there is property of matter known as specific heat. Which controls for a given amount of solar insolation and terrestrial radiation. Heating and cooling of surface. Of course, solar insolation incoming, terrestrial radiation outgoing. Outgoing terrestrial radiation is source of cooling. Incoming solar insolation is source of heating. Incoming solar insolation and outgoing terrestrial radiation is source of heating, source of cooling. Remember that specific heat, we are taking geographical condition of water is maximum. Then land surface is relatively, specific heat of land surface is relatively low, and then land cover with sand and stone. Land covered with sand and stone has minimum specific heat in relation to the land. Land means normal condition of the land. Water has maximum specific heat. So, for a given amount of incoming shortwave solar insolation, temperature of surface is inversely proportional to specific heat. For a given amount of incoming shortwave solar insolation which is absorbed and retained by a given surface, temperature of surface is inversely proportional to specific heat. So what is the conclusion? As well as range of temperature is also inversely proportional to specific heat. Range means fluctuation of temperature. Fluctuation of temperature occurs, heating occurs during daytime and summer season, cooling occurs during night time and winter season. That you people already know. Shall I draw the conclusions? We need these things. We do not need to write into the mains. These are the part of the basics. Like while you are studying mathematics in higher studies, every time you do not write that sin theta by cos theta is tan theta. Okay, now just these two things. Temperature of a given surface is inversely proportional to specific heat. So tell me one thing, annual temperature of northern hemisphere is going to be greater than annual temperature of southern hemisphere. That is the first conclusion. Because northern hemisphere is dominated by continent, southern hemisphere is dominated by oceanic surface. It is clear? You people have written? Next point. In the summer season, at a given latitude, continental surface is hotter than oceanic surface. Continental surface is hotter than oceanic surface. And in the winters, oceanic surface is warmer than continental surface. It is clear? At the same latitude, in the summer season, as we travel from the oceanic surface to continental surface, that is going to be hotter. And in the winter season, as we travel from the continental surface to oceanic surface is going to be warmer because of the less drop in the temperature over oceanic surface. Next point, range of temperature increases, range of temperature या fluctuation in temperature increases from oceanic surface to continental surface. So what is conclusion? Greater is a distance of a place from the coast, more is variation in temperature. More is variation in temperature. Like Chennai and Bangalore, Chennai and Hyderabad, same latitudinal zone, which is going to have more fluctuation. Bangalore and Hyderabad. Deeper we inside go to the continents, more is going to be fluctuation in temperature. That is called continentality. That is called continentality. Delhi has a reflection of continental climate. Jaisalmer has a reflection of continental climate. Ajmer has a reflection of continental climate. Bikaner has a reflection of continental climate. Marine climate, marine influence या oceanic influence, Mumbai, Chennai, Kolkata, they have oceanic influence. Getting this thing? So this is related with the distribution of land and water. What is next? Winds अलग है, oceanic currents अलग होगा ना? Yes, thermal properties of inflowing winds. In detail, we are going to study in the winds, which are the next topic, pressure belts and the winds. Here just I am giving the reference. Temperature of a place rises under influence of inflowing hot winds. Like you can give example of Lu. Yeah, heat waves flowing into Delhi during summers from the Thar desert. And temperature of a place decline under influence of inflowing cold winds. Next, currents, oceanic currents. A place under influence of cold currents, a place under influence of inflowing cold oceanic currents has low temperature compared to a place under influence of warm oceanic currents. Like I am giving you example. This is inflowing Labrador current, and this is called North Atlantic drift. These two currents are located in Northern Atlantic. This is along the west coast of the Europe, and this is along the northeastern coast of Canada. We take a given latitude. Place A is going to be warmer than place B. A place which is located at the same latitude but along the coast of Canada is going to be colder because it is under influence of Labrador current. The place at the same latitude located on the west coast of Europe, northwestern coast of Europe, is going to have relatively high temperature. That is why northwestern European coast are free of ice even during the winter season because of the North Atlantic drift, which is a warm current. आगे चले. What is last? Distribution of plant and vegetation. Remember that plant and vegetation help in moderation of temperature. That is what every day we are saying. The extreme conditions of temperature worldwide and in India are result of deforestation. Plant and vegetation helps in moderation of temperature. Means they help in reducing fluctuation of temperature. They help in moderating heat wave and cold wave conditions. So these are the factors and trends of global distribution of temperature. There is any question related with the global distribution of temperature? No, there are. So this is all for today. Because time is up, we cannot start the new topic. Tomorrow we are going to study pressure belts and winds. Next section of the climatology. All the topics related with temperature, surface and air temperature are over. We have covered heat budget and related questions. We have covered composition and structure of atmosphere and global distribution of surface and atmospheric temperature and temperature inversion with the all PYQs. None of the PYQs are left. Any question, any doubt? You people are able to understand? Yeah, means just in the class for the sake of being in the class. You people are really interested in civil services with the intrinsic motivation coming from inside. Yeah, imposed by your parents, your peer groups, your friends, your grandparents and grandmothers to prepare for civil services, and you people are willingly preparing for the civil services. Any recommendation to improvement in the teaching? Yeah, it is okay. You people have bought this one? How many people have bought this one? Frankly telling you, don't go to the any coaching and teacher without syllabus and without PYQs. Otherwise, they are going to fool you. Don't go to the any class related with the civil services, yeah, any kind of competitive examination, yeah, any kind of examination. Even if you are appearing in the high school and intermediate, you need to have the PYQs and the syllabus before you. Otherwise, you know that you are going to be cheated, and then you will cry on the roads. The coaching wala are charging so much and teaching nothing. Who is teaching students? Who are making students more variable? Students who have qualified civil services. by creating narratives, false narratives. How many topics? 6 hours I have taught. How many topics I have covered? 4 with the PYQs. And my speed is relatively good. It is not slow. And someone says that they will teach you geography in 3 months. So this week we are going to have 5-day class, 2 to 5, Monday, Tuesday, Wednesday, Thursday, Friday. Maybe if situation arise, conditions arise, we are going to have 6 days classes. But in the beginning, 5 days classes, 2 to 5. It is okay. Remember that 2 sections are tough, geomorphology and climatology. Rest are derived from knowledge we have acquired through climatology and geomorphology. You are studying toughest of the section. It is not the easiest one. Rest of the sections are easier one. If you understand the heat budget, easily you can explain the global warming and climate change. Chalo, to all the best. No question arise. My teaching is so perfect. Yeah, my students are so perfect. Offline classes, running offline classes are too difficult now. Situation is still volatile. Even though grievances of the students have been addressed, you know that there could be some vested interests. And some of the teachers, some of the coaching institute, set the students to cry, to demand their presence, so that they get media attention. You people should use your common sense and cleverness. ऑफलाइन क्लासेस जल्दी ही शुरू हो जाएगी, क्या लग रहा है? क्योंकि देखो ऑफलाइन क्लास शुरू करने में डेंजर भी है, डेंजरस सिचुएशन भी है. Atmospheric conditions in the old Rajendra Nagar are mercurial in nature. Temperaments are high. And you know that students in the crowd work according to the crowd psychology. They tend to lose their common sense. In fact, they should demand restricting number of students into the classroom, rather than going after the basement, and all that. They should demand for restricting number of students into the classrooms. Like up to the 40 to 50, not more than 50 in any situation. They are misguided. Like hazards are common in India. Hazards are preventable to become disasters. And that is preventable through optimizing the number of students into a classroom. restricting the number of students like 40 to 60, not more than 40 to 60 in any situation. So that teachers can have face-to-face interactions too. Face-to-face interaction and understanding of the problems faced by the students and the respective solutions.